average value, you have learned a lot about average value over the years. You've learned average value with a finite number of things where you add all of them together and divide by how many there are. But realize that we also have different meanings to the word average because there's the whole mean, median, mode, and all of that. You need to make sure you're clear about what the meaning of the word average is on the AP test, and I'm going to discuss that at the end of today. So first of all, one idea of average value is, say you have a model representing the temperature over a 24-hour time period, and you want to know what was the average temperature that day. This shows you what the average temperature was that day, and you can also see that you were at that average temperature a little bit before noon and a bit more than that before midnight. So that's should make relatively decent sense about what they're meaning with the word average. Now, I want you to look at this graph right here. And let's call this x equals A, and let's call this x equals B. And I want you to look at these numbers and approximate what you think the average value of this function. So from here to here, what do you think is the average value based on this lowest point is like 1.3-ish. This highest point is like 3. I don't know, 8 something. But I want you to think, what do you believe is the average value? And write down that answer in chat, and let's see who gets closest but answers first to the closest number. And then the Jeopardy music. So the average value is looking at the y values of the function. If you look back at the temperature model that I just showed you, the average temperature was the y value, the x was time. So I want you to take a guess at what you think it is, because I want you to get a feel for it. And let me give you time for more guesses. Okay. So far people have given answers of 2.1, 2.2, 2.3. I've got a 2.5. I've got a 2.4. Now, here's what I want to share with you. Whatever the average value is, and I'm not going to draw right now at a line that is exactly the right number, but whatever it happens to be, if I come over here and I draw I'm not doing that, draw a horizontal line. I'm trying to draw a horizontal line anyway, between A and B. And then vertical lines at A and at B and the x-axis. You get a rectangle. If that average y value was the right number, the area of that square is identical to the area under the curve. But I wanted you to first see for yourself just thinking about what the average value is, just looking at it. So what I'm going to write down is that the integral from a to b of this function, that is equal to the area of that rectangle. Now, the area of the rectangle is whatever f average is, a y value, multiplied by what is this length based on generic a and b. With generic a and b, what is the distance along here? I see it, b minus a. And what that does is it provides us with a formula for how to find the average value. If I divide by b minus a, this is a very, 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 very important formula. If you want to find the average value of a continuous function from a to b, you integrate that function from a to b. And if you think about it, integrating is like adding a bunch of things up, and then you divide it by the length of the interval. So you can see some similarity to adding up a bunch of finite numbers and dividing by how many there are. There are similarities to that. Now, I'm going to show you the picture with the correct average rectangle drawn in. And the answer is, and I kept this where it was, 2.42499. So the winner is the first person who answered 2.4, which was Dylan Drennan. Woo! Go, Dylan. You won bragging rights. So this I found on the internet and just kind of worked with it a little bit. You can change the function you want to look at. And as you change a and b, it will show the average changing with it, even going into the negative arena. It will keep looking at what is the average value. So you may find this fun to play with, and I will try to remember to put a link for this for you to play with. But it allows you to really see that meaning of average value. That's the purple rectangle. I mean the y coordinate of the purple rectangle. Okay, then, yeah. So there's your formula that we just talked about. Also, just to make you aware of a mean value theorem for integrals, know that when you see the phrase mean value theorem, you want to refer to what we learned previously, that when the AP test mentions it. This is talking about the fact that the average value of your function must occur somewhere in between the region you selected. So I'm going to go back to the picture in a second, but I see that some of you are writing this down. This is in your textbook. I'm going to come back to this, but I'm going to real quick head over to this picture to point out to you what that is meaning. So F average is, I'm trying to accurately mark that, is a y value over here somewhere. You are guaranteed that there is at least one x coordinate, C, between A and B, such that f of c is equal to the average value of f. It will happen for at least one x in between a and b, but it could happen for more. And so there's the theorem again, but I want to get into some examples with you, and you can copy that down later. You can pause the video or look it up in your textbook. So, oh, yes. I'm going to get to that after we do examples. Okay. So in your homework, some of your homework involves the odd problems that you see here. And know that the main purpose of a lot of the homework problems today are for you to practice integrating, because the average value part of it is a snap and you're done. So down here in the directions 9 through 12, this first part A is asking you the same question as 1 through 8 are asking you in total. So part A is just find the average value of the function over the interval. And I'm going to go through number 10 with you to make sure you're clear about what these directions are asking you to do. There are a couple problems after these, but I just want to make sure the directions make sense. So for part A, when you are asked to find the average value, you're going to go, all right, 1 over b minus a, integral from a to b of the function dx. There, that was your average value moment. Now, integrate. So x to the 1/2, add 1 to the exponent. Don't forget that there's a 1/4, evaluating from 0 to 4. So let's see. That's going to end up being 1/6 times. When I plug in 4, square root cubed gives me 8, and then a minus 0 when I plug that in, and that simplifies to 4/3. So that means that 4/3 is the average value if I'm looking at the function root x. I'm going to draw a quick version of root x. And then let me just kind of approximate that maybe this is 4 right here. That means that this is 2. And the average value of 4/3 is about right here. Now, the second thing they're asking you to do is find the c such that f average equals f of c. So what you're going to do is you're just going to take the f of x function, set it equal to the average value, and solve. So root x, when does it equal 4/3? When x is 16/9. And 16/9 is a little shy of 2. So it's like maybe about here. And I drew an approximate graph anyway. But you will find if you draw this on a computer, you will see that this matches perfectly, that the average value of 4/3 matches with the x coordinate 16/9 as a point on that function. And that in part C, it's asking you to sketch this picture that I just started. So you're going to graph the f of x function. You're going to look at what the average value is and the x coordinate. And then you're going to draw a horizontal line. Cut it off at your A and B. Cut it off at your x-axis. And this is the rectangle that it is talking about. So sketch the graph of f and a rectangle whose area is the same as the area under the graph of f. So that's what you're going to do. You don't have to shade, but, you know, there you go. So average value is really, really pretty straightforward. The only issue is you need to understand when you hit the AP test that the word average shows up in two different circumstances, because you can't just use any average formula. You have to use the average formulas that calculus expects you to be using. So here's our average value. If we are asked for the average value of a function f, we use this formula. If you're asked for the average rate of change of a function, you're actually finding the slope between the endpoints. So these are two places that the word average will show up. Now, do you feel bothered by having two different formulas? Guess what? They're not two different formulas. Let me show you. If I change what I said was function f to function f prime. So when I say find the average value of the function f prime over the interval a to b, then you're integrating f prime. Then I change the g function to being the f function. So average rate of change of f is the same thing as saying average value of f prime, right? Average rate of change of f is the average value of f prime. They are one and the same, and if you look at what the integral does, when you integrate f prime, you get f. You will plug in b minus plug in a to the f function. And do you see that it is exactly the same formula? So it's really important to point out to you that these genuinely are the same formula. So when you hit the word average in an AP problem, you want to be thinking about slowing down and reading the words very, very carefully. Who exactly is it asking you to find the average of? And is it an average rate of change or an average value? And what's beautiful is if you read it in a kind of different twist than maybe you were supposed to. Let me say this. I watched someone on a test be asked to find, say, average velocity of a function, and they were given the displacement function. So if you are given displacement and you're asked to find average velocity, you're going to throw a slope formula in and be done with it. Wait a minute, I just said that differently than I originally said it, didn't I? Let me start again. So they were given the velocity function and they were asked for average velocity. All they needed to do was integrate velocity. But instead, they went, I may be remembering it backward now. But basically, if you say, why am I not remembering it correctly? And it's recording right now, so it's recording my mumblings. But basically, if you start again, here we go. You're given the position function, you're asked to find average velocity. You should just throw it in a slope formula and be done. This person thought, if I need to find average velocity, I need to integrate velocity from a to b and divide by b minus a. So what they did was they took the position function, found its derivative, velocity, and then integrated it and went through the entire integration process without realizing that they were literally going backward on what they just did. and then plugged in the b and the a and divided by b and a minus a, got the right answer. So you can do this problem in a totally convoluted way where you literally go full circle and come back to what you are actually supposed to do at the very, very end. It all means the same thing, is what I'm trying to express. All right. Then that's all that I needed to tell you about with average value. And today's quiz is rotational volume. Tomorrow's quiz is cross-sectional volume. And you wanted to take a look at those two problems. So let me find the textbook. I've got it somewhere in this myriad of... Nope, not there. Do I have it there? Yes, I do. I found it. Okay, so 8 and 16. And then I'm going to grab 16 while I'm at it. And this is probably a good quick review also, right before going into the quiz. Okay. You will have a calculator on today's quiz. So if you have struggles with graphing, you don't have to worry about it at this point. Graphing the parabola, and graphing the other parabola, I am not drawing this to scale. And the intersection points need to be found. Make sure you know how to find intersection points with your calculator. And without a calculator, though, you need to set them equal to each other. If you're planning on taking the AP test, you need to make sure that you know how to do this without a calculator. I'm going to get out of fraction land by multiplying 4 all the way through. And now I'm going to get 5x squared equals 20. So I'm getting that my intersection points are plus or minus root 2. So this region is rotated about the x-axis. When I'm prepping for this problem, I draw my radii. From the axis of rotation to the furthest function is my outer radius. From the axis of rotation to the closest function is my inner radius. And when I find their lengths, I have to make sure that I am finding a top y and I'm subtracting a bottom y. Now, if my radii are lengths that are vertical, that means my tiny, tiny cuts are horizontal, and this is a dx integral. So I put the x values of the intersection points, and then I prepare the geometry formula of pi times outer radius squared minus pi times inner radius squared. For the outer radius, the y value of the top is 5 minus x squared. The y value of the bottom is 0, which you don't have to write. For the inner radius, the top y value is the 1/4 x squared, and the bottom y value is 0. From there, it's a matter of solving the integral, and on the quiz, you will have a calculator to solve the integral. Then number 16. we have y equals x and y equals root x. The intersections are at 0, 0, and 1, 1. And there's my region. I'm rotating it about x equals 2. X equals 2 is a vertical line. When I draw my radii, I start at the axis of rotation and I draw perpendicular toward the region to the function furthest from that axis of rotation, and that is my outer radius. Then from the axis of rotation to the closer of the two functions for my inner radius. The outer radius goes into the region to its far edge. The inner radius just goes to where the region is about to start and does not go inside the region. Then I look at the fact that my radii are horizontal. When I go to find the lengths of my radius, I need to subtract a right x coordinate and a left x coordinate. And if my radii are horizontal lengths, that means my tiny cuts are vertical distances. And that means this is a dy integral. And then the y values are 0 and this one. And then I go through again the formula pi times outer radius squared minus pi times inner radius squared. And if you run into a pure disk method, it's just easier. You don't have to deal with the minus pi times inner radius. And it's completely attached to the axis of rotation from C to D if it is a disk, a pure disk. So then I now want to write down my radii. My right x coordinate is 2. Minus my left x coordinate on the outer radius is the square root function, but I have to say what x is equal to. So I have to square both sides to see that the left x is actually x equals y squared. Then for the inner radius, the right x is 2 minus the left x is equal to y. You want to be extra careful if you have to deal with a dy integral. Make sure that only the variable y is showing up in your integrand. That will often catch some of the common mistakes that people make. And then make sure that these limits are y values. And from there, do you have any other questions before I throw the quiz your way? And now I need to actually find you because I can't see you right now. There you are. Okay. And if dx only x right. I'm not sure what that question was. That question answered? Okay. So if dx, then what? I'm not sure what the question is. Oh, if we're using Desmos. You know what? That is a very important question. If you are using Desmos, you have to make sure you put into Desmos the full integral formula. So I'm just going to quickly throw in, let's say f of x is equal to x and g of x is equal to root x. This darn thing is in the way. Hide root x. No, that's not what I wanted. It changed on me. There we go, root x. Okay. So if I'm rotating about the x-axis, when I set up the integral, I need to fully put in proper formulas. So I'm going to put in the 0 to 1, 1. Then I'm going to put the pi completely factored out of the whole thing, parentheses, parentheses. Then I have the g of x function, technically minus 0. I'm throwing that in just for the in case purposes, squared, minus, and then another parentheses for the inner radius, which will be f of x squared, and then a final end parentheses dx. So you'll have to type in the whole thing, but you can use the function names. All right, I'm going to stop recording.